In today's video, I'm going to show you how to import a 3D model that's been created in another package. Maybe export it out to a step file, bring it into Inventor, and then convert that into Sheetmetal component, because that's what it originally was, and flatten it. Now, the first thing I'm going to do is we're going to go File, Open, and at the bottom, if you aren't able to find, say, the step file that you've got from your client or colleague, just make sure that you go to Files of Type and make sure that step files or all files are filtering out. So there's my step files. So there I've got front.step. Select the front.step file, click on Open, and this import dialog box comes up. Now, because it's a step file, we can use the AnyCAD technology to reference the model, but then we can't really work on it. So what we're going to do is we're going to convert this because we want to flatten it and then create drawings from it from there. Now we have some object filters, just bring in the solids or the surfaces or the wires, etc. I'm going to leave that all as is. And I'm actually just going to go through to OK. But just one thing before I do that, if you go to a property mapping, you'll notice that if this has come from another software package, you're able to map the Inventor property to a property that is coming in from the other software package. Okay, so you'll see that I've got CATIA, Pro-E, and Creo, NX, Solid Edge, Step, and SolidWorks. So any of the I properties or the metadata that's residing in those software packages, if I need them to come through as well, then I will just then make sure I've got the correct mapping to be able to get things like part number, description, etc. coming into my part. Okay, so once that's done, I click on OK, and you'll see that it comes in pretty quickly. Now, the first thing that you'll notice is that it says it's a solid part. So yes, when Inventor does bring in, it is able to open up parts from another software package or a step file, but unfortunately, essentially, it's a dumb model, but there are ways to go and manipulate this. Okay, so the first thing I need to do is I need to convert this to a sheet metal part. So I'm going to go say convert to sheet metal. And then what you'll notice asks me to do is select a face or a base face. And the base face I'm going to say is that face over there. And it does two things now. It first selects the base face, and also what it does, it automatically picks up what the thickness of that is. Okay, it hasn't picked up this thickness. Okay. I'm going to click on OK over here. Okay, so it hasn't picked up the thickness, but I'm going to get around that. So what I'm going to do is I'm going to just measure what the thickness is. So let's go over here. And the thickness is, okay, it's 0.12 inches. So it actually was that thickness that it did pick up over there. So I'm going to go back to my sheet metal defaults. I'm going to say use thickness from rule 0.12. That's fine. And what I'm going to do now is go and flat pattern it. So create flat pattern. And there we go. So it creates it. I can see my bend lines. I can see my fold lines, etc. Okay, so there we go. Going back to my folded parts. So that was the easy part. So I've got that. I can now go create my 2D drawing out of it if I wanted to, IDW. Now, what happens is how can I manipulate this? So say, for instance, we've got this, and maybe we don't need, every second hole, just for instance. So what you can do over here is if I go to my 3D model tab, I've got a delete face option. Now, if I select on delete face, I'm just going to do the one for now, and I go heal remaining faces. I click on OK, it actually makes it disappear. Okay, so I can select more than one if I wanted to. Just make sure I'm selecting the faces over there. And then select delete face, make sure to have heal remaining faces, and OK, and there I've got those over there. Now, obviously, you can create a new hole if you wanted to as well, so it gives the opportunity or the ability to do that. Another thing it allows you to do is also move the hole. So maybe you want to kind of space it out a little bit more. All the holes have to move maybe 3 mils to the right, because the component that you're bolting this onto is, the holes are just sitting in a different place. So maybe I want to grab all those holes and maybe move it 2 millimeters to the right. So what I can do with this is take a look at it from this side over here, go through to my 3D model, and then what I've got is my direct edit feature. So select the direct edit feature. Okay. Make sure that you've got faces and not solids selected. And then what I'm going to do is I'm going to go and select. So I'm holding down my left mouse button, dragging a window across that. Now, what it's also done is it's just selected that front face over there and the back face. So I'm going to go and hold down my shift button and my control button and deselect those faces. So now what we see is we've just got these holes selected. Now, if we take a look at the UCS over there, the triad, I can move it up, down. So I'm going to grab that arrow over there, and you'll see I'm able to move it to the right. Okay, so 0.65 inches. I'm going to say 5 millimeters, just to show you that we can use both millimeters and inches. It understands it, and it will move it the appropriate length. 5 millimeters, press enter, and you'll see there now we have shifted our holes 5 millimeters to the right. Okay, so that is how easy it is to manipulate the drawing. Once you've brought it in, even though we don't have all our features like the edit, the extrude or revolve or actual hole wizard that comes from another package. So if you are doing a lot of Sheetmetal components which are coming from somewhere else, and it's either a step file or a competitor package to Inventor, then you can just use the direct edit to manipulate it. Thanks very much for watching.